Today we will begin Lesson 2, Powers and Exponents. We've already put a foldable in our math journal to get us started with powers and exponents, so this should be a fairly simple lesson. Let's take a look at the essential question. The essential question is, why is it helpful to write numbers in different ways? Last lesson we learned to write numbers from fractions to decimals and decimals to fractions. Today we're going to learn why it is helpful to write numbers using exponents. Our vocabulary in this lesson is power, base, and exponent. We talked about base yesterday, and we talked about exponent yesterday, and I told you that when a number was written with an exponent, it was called a power. Our Common Core State Standard for this lesson is 8.EE.1. Remember that EE stands for expressions and equations. Okay, on page 16, we're going to write and evaluate powers. A product of repeated factors can be expressed as a power, that is, using an exponent and a base, just like we wrote yesterday in our journal. 2 to the 4th power, the base is the common factor, or 2. The exponent is how many times the base is used as a factor, and so it would be 2 times 2 times 2 times 2. Powers are always read a certain way, and you have a little chart here in the middle of your page. 3 to the 1st power is 3. 3 to the 2nd power, or sometimes we say 3 squared, is 3 times 3. 3 to the 3rd power, or sometimes we say 3 cubed, is 3 times 3 times 3. 3 to the 4th power, or 3 to the 4th, and it continues on from there. At the bottom it says 3 to the nth power, or 3 to the nth. That just shows that it could have any number of factors. All right, let's take a look down at the bottom. Write each expression using exponents. There are some examples here. -2 times -2 times -2 times 3 times 3 times 3 times 3. The base is -2, is a factor 3 times. And the base 3 is a factor 4 times. So we would write it -2 to the 3rd times 3 to the 4th. Number 2, a times b times b times a times b. This time we have the base a, which is a factor twice, and the base b, which is a factor 3 times. So it would be written a to the 2nd times b to the 3rd, or a squared times b cubed. Let's look down at the bottom. We have some examples. A says 1/2 times 1/2 times 1/2 times 1/2. Well, our base is 1/2, and it is a factor 4 times, so we would write it 1/2 to the 4th. You don't need the parentheses there, but sometimes it makes it less confusing. Go ahead and work B and C in your book using the examples above, and write the answers over to the left. There's no work to show. And then come back to the video so we can go to the next example. In example 3 on page 17, it says evaluate -2/3 to the 4th power. That means that we're going to write -2/3 times -2/3 times -2/3 times -2/3. Remember, when multiplying fractions, that you multiply the numerators. So we've got 2 times 2 times 2 times 2. So 2 times 2 is 4. Times 2 is 8, times 2 is 16. Then you multiply the denominators, 3 times 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27, times 3 is 81. So we have 16 over 81. Now keep in mind we had negatives up here. But if you think about it, when you multiply a negative times a negative, you get a positive. When you multiply another negative times another negative, you get a positive. So that makes our answer positive. Anytime you multiply an even number of negatives, you're going to get a positive answer. Conversely, if you were to multiply an odd number of negatives, you would get a negative answer. Let's look at D on page 17. We have 4 to the 4th power. So we would multiply 4 times 4 times 4 times 4. 4 times 4 is 16. Times 4 is 64, times 4 is 256. So our answer to D would be 256. Pause your video and go ahead and work examples E and F in your book. You'll need to show work right underneath them. And remember, when multiplying fractions, you multiply the numerators and then you multiply the denominators. If you need extra examples, remember that you have the tutor on your online textbook. So if you go to your online textbook, and if you recall when we went through it, down at the bottom there will be a purple button. If you push that, click on that purple button, it should bring up another teacher showing you some more examples, and that's the case throughout the book. So go ahead and pause it, do those two examples, and come back. Okay, let's look at example 4 on page 17. The deck of a skateboard has an area of about 2 to the 5th power times 7 square inches. Remember that area is always in units squared. What is the area of the skateboard deck? Well, we would take 2 to the 5th times 7. So 2 times 2 times 2 times 2 times 2 times 7. So we're writing that power as a product. We're going to multiply it out. When we multiply our 2's together, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So we get 32 times 7, or 224 square inches. So the deck of the skateboard is about 224 square inches. Let's look at the problem below it. A school basketball court has an area of 2 to the 3rd times 3 times 5 to the 2nd times 7 square feet. What is the area of a school basketball court? So the first thing we'll do is write it as a product. 2 times 2 times 2 times 3 times 5 times 5 times 7. And then we have a lot of multiplying to do. So we have 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So we know that when we multiply these together, we have 8 times 3. 5 times 5 is 25, so times 25 times 7. So we have 8 times 3. We put that up here, 8 times 3 times 25 times 7. 8 times 3 is 24. 25 times 7. Well, I know that 25 times 4 is 100. And 25 times 3 is 75. So 25 times 7 is going to be 175. And then when we multiply 24 times 175, we're going to get 4,200 square feet. So that's a lot of multiplication. Sorry. That's a lot of multiplication, but it's not difficult multiplication. So you would put your answer over here. And I'm sorry I didn't move that earlier to show you that I put my answer for letter D here, and you should have had your answers for E and F also over to the side. All right, let's move down to example 5. Example 5 says evaluate each expression if A equals 3 and B equals 5. So this time we're just doing a substitution. So if A is 3, we will put 3 where the A is, substitute it for A, and if B is 5, we'll substitute 5 for B. Notice they've done that. 3 to the 2nd plus 5 to the 4th. And then we're doing just what we'd already done. Write it as a power, multiply it. 3 times 3 is 9, 5 times 5 times 5 times 5 is 625, and when you add it together, you get 634. Below that, we have A minus B to the 2nd power. Now remember, we're also using order of operations here. So we have 3 minus 5 to the 2nd power. We need to do what's in grouping symbols first. 3 minus 5 is negative 2, and then negative 2 to the 2nd power. Negative 2 times negative 2 is positive 4. Remember, when you multiply two negatives, you get a positive. So in just this one problem, we've used our integers rules, we've used our order of operations, and we've also used our new knowledge of exponents and of substituting in order to evaluate these expressions. Let's take a look at page 18. In example H, we have C to the 3rd power plus D to the 2nd power. It tells us that C is negative 4 and D is 9. So we're going to have negative 4 to the 3rd power plus 9 to the 2nd power. Let's write it as a product. I'll move my hand so you can see it. As a product, it's negative 4 times negative 4 times negative 4 plus 9 times 9. We know that 9 times 9 is 81. Negative 4 times negative 4 is positive 16. Remember, two negatives equal a positive. And positive 16 times negative 4 is negative 64. So we're going to add negative 64 plus positive 81. When you add those together, you should get positive 17, and we'll put that up to the left side by H. Go ahead and pause your video and do letters I and J. And when you finish, write your answers over to the left and then bring your book back tomorrow so that we can review your notes and your lesson.